All right, this is Tinker CAD, and I'm going to create a new circuit. When I do that, it should open up a blank screen. I have my tools on the right. I want a breadboard, so I have to drag that one in. I want some batteries. I'm going to get 3 1.5 volt batteries. And I'm going to hook them together. I'm going to hook the battery into the red for the hot line. I have to click on there to connect that. I'm going to connect the battery black to red, black to red. It's like you're stacking them up in order. I'm going to hook the negative of this last battery, the ground, into the black row, which is the ground. I'm going to hook this ground on the top to the ground on the bottom, and this hot wire, the plus 4.5 volts, down here. I'm going to go back and change a couple of colors just to make it look pretty. The hot ones, the plus 4.5 volts, are going to be red. I'll change the grounds to black. I'm not going to change the other ones in general, but I just like to do this for the ground wire and the constant supply wire. All right, now let's put an LED in there. If we put an LED in, it's a red LED. We need to have a resistor as well, so that's going to hook in. Let's change that resistor to 220, because that's a pretty common one at work. It's supposed to work with the LED. You can see the bands change color there. Now if I hook the hot wire, which is 4.5 volts, because it's got 3 1.5 volt batteries in here. So I make a connection there, a little wire. It's going to go, electricity is going to go through there, through the LED, connected to the resistor, through the resistor, and then add another wire down to ground. So the electricity is going to go from 5 volts, it's reduced the voltage and ends up at 0 volts on the ground. Now if we run the simulation, the wire should light up, or the LED should light up. Let's do the same thing, but let's put a green LED in there. Hook him up. Put a resistor in. Hook that down. Now if we run the simulation, both of them light up. Very good. We can take a button and put him in there. All right, we have a button. We're going to change it out. So delete this wire. Select the wire and hit delete, and it should go away. This button is going to take electricity from the bottom rail. When it's high voltage, it's going to go through the button, across the button to this point, this row, column up here. So we're going to hook him together with the red LED. Now when we run the simulation, we know it's working because the green light is on. If we click on the button, the red LED turns on. So we know that our button wiring is connected and it works. So that's just a little example of doing stuff with just batteries and circuits, and there's lots of circuits out there you can do without adding a more complex Arduino into the mix. But let's now pull in an Arduino and see what we can do with him. So this Arduino down at the bottom has a plus 5 volt. I'm going to hook him in to the bottom rail this time, and a ground. So my plus 5 and ground are still there. So the circuit should actually work the same. When I run the simulation, it's just like it's supplying battery power. So it's the same circuit. Green light is running. The red light runs when I push the button. So everything works just like it did before. But if I run that simulation again, you might notice something. You see this LED is blinking? That's the built-in LED. Usually an Arduino has a LED saying it gets power and it's turned on, it's okay. But it usually has a built-in LED, and it's usually tied to pin 13. So that LED is running a program, and the program for that is under this code. So when you look at the code, you see there's a built-in, set the built-in LED pin 13 to high, wait a second, set the built-in LED to low, wait 1 second, and then cycle over and over and over and over. Now, hide that code. We are going to, oops, let's see, I want to get this wire, if I can get him, select him. I'm going to change it so pin 13 is hooked into that red LED. Now when I run the simulation, every time the pin 13 turns on, it's basically going to turn on the red LED. So this onboard LED blinks, the red LED blinks, and that's working. Let's stop that simulation and change up the green LED as well. So we'll put the green LED, connect him as an output into pin, let's say 12. All right, we don't have any code turning on pin 12. So go back in the code. Now I want to change this around. I'm going to take this away, throw him away. And I'm not going to use this set pin 3 to a value. That's the analog or pulse width modulation. You can do something sort of like analog with outputs. We're going to use this that only does high and low. So I'm going to get 2 of those. And I'm going to set pin 13 was my red one. I'm going to set him to high. I'm going to set pin 12 to low. And then trash those guys. Get 2 more copies for 12 and 13. So we'll do 13, make him go, he was high, so we'll set him to low. And 12 was low, so we'll set him to high. Close that code, run the simulation, and the 2 lights should blink back and forth, red to green to red to green. So every second, it's going to switch back and forth. Now for the button, that's where it gets a little tricky. We have to take that wire. He was hooked into the high voltage. I'm having trouble selecting that wire. All right, we're going to hook him into the ground. We're going to hook the other side into pin 0. And I'm going to go down here and get a multimeter. And he's going to measure voltage. He can measure current as well, but we're going to have the negative hook into the ground for our system. And we'll hook the positive in right here. So he'll measure the voltage on that pin. So when we start the simulation, we haven't changed any of the code. When I push that button, there's right now that button, the pin 0 is reading 5 volts. When I push the button, it goes to 0. So let's stop the simulation, go back into my code. We need an if then else statement. How about? Let's use an if then else statement. In one case, we're going to do one thing. Let's get rid of those weights. We don't need the weights anymore. So we're going to switch between, if some condition is met, let's use, I like to use a less than or equal to. Let's do a sensor. Where's our sensing? Inputs. Our input, read digital pin. We're going to read digital pin 0. So if he is less than 1, we're going to do something. Otherwise, if he's high, we're going to do something else. So if we push the button, when we push the button, it should drop that pin 0 to 0. So let's see if that works. So if we push the button, the red will be high on and the green will be off. Otherwise, it should be green. That's what my prediction is. So when I run it, I'm not pushing the button, green is on. But as soon as I push this button, it's going to switch to the other state. And there's lots of things you can do. You can put timing, you can make more complicated code. It seems very simple, and it is pretty simple. But this is really a neat toolkit, or a neat area to mess around in with Tinker CAD. There's a lot of things you can do. Let's see. Let's go back and make a brand new clean circuit. There's different pieces you can play around with and see how they work. There's lots of projects. You can take a 9-volt battery, and I have a lamp in here I think I saw. Where's that lamp? There's a motor. Let's hook them into a motor. So if I have a motor, I'm going to hook positive. When I run this simulation, he should spin pretty good. It tells you how fast he's spinning. Let's see. I think there's also a potentiometer. We can use that to change the resistance. So right now, we put a little resistance on there. I think he's going at 17,000 RPM. We can dial it around and change the resistance, which has some effect on the speed. It's not a great control method. I think I've probably not done a great job setting up the potentiometer, but that's one way you're changing resistance. You could put a switch on there. You don't have to use a breadboard for these, as you can see. So I can turn on and off my motor. By changing my potentiometer, I can change how fast he goes. Where's the lamp? I thought there was a lamp in there. Maybe that's not in basic. Maybe it's not in there anymore. Anyway, so there's lots of things you can do. There's motors, there's different batteries, all sorts of different things. Gear motor, that's a good one, because you can adjust speed on him a little easier. This DC motor, gear motor has gears. The DC motor just goes forwards and backwards. One of the interesting things about a DC motor, if you wire him up backwards, you can wire him up instead of red to red, red to black, and he'll go the other way. He should go backwards. So the gear motors, I think, don't go backwards. So you can play around with stuff without breaking it and wire it up, and you can follow demonstrations. There's lots of examples out there. You can look at tutorials and figure out how to wire stuff up without having components and see how they work and try them out and try and understand why they work that way. That's the trick, not just to follow a recipe, to actually understand enough that you could have a feel for how to hook things together to make things work.